Welcome to my video. I am Dr. Satyanarayan Rao and I recently applied to a research software engineer job at a reputable organization, and in this video I wanted to share my experience with the interview, what kind of questions I was asked and how I approached them and what the interviewer followed up with. And so it's basically an optimization problem in Python and in scientific computing. And I would also like to clarify that the problem I'm going to share in this video, it's not exactly the same questions I was asked during the interview. I have worked to make it look similar but not the identical. And so I won't be naming the employer, nor I will be sharing the exact questions or exact problems, because I respect the effort that went through in designing it. And so it will be a similar problem. And so let's go through the challenges that I was given and how I responded it and what else I could have said. So let's begin our video. So the first question I was asked about is optimizing a function that computes some kind of distance or comparison between numbers, variables, or it could be string, like the Euclidean distance shown here. And the function computes pairwise distance matrix for 3 data points as seen in this example. And in this computation, the function actually uses 2 loops. And when I is 0, it actually computes 0, 0, 0, 1 and 0, 2. And similarly, when I is 1, it computes 1, 0, 1, 1 and 1, 2. And when I is 2, it computes 2, 0, 2, 1 and 2, 2. And the problem is some of these computations are redundant. For example, we have self-comparisons between the I, or 0, 0, 1, 1 is always 0, since the distance between two identical numbers or variables is always 0. And we also have distance between A and B is same as distance between B and A, so it's symmetric. So the interviewer asked me how I could optimize this function. So my suggestion was straightforward. So I suggested that first I would initialize the diagonal matrix as 0 directly, avoiding unnecessary computations, because right now everything is computed. And second, I suggested that we could compute the distance or comparisons only in the upper triangular matrix when the index j is greater than I. And so finally what we could do is we could use the symmetry of the matrix to copy the upper triangular matrix into the lower triangular matrix so that the ij is same as the ji. So by doing this we can reduce the computation by 50% and we are avoiding the redundant calculation entirely. And so the interviewer seemed happy about my responses, and so we will go to the next question that he asked me. So then the interviewer asked me what else we could do if we were given a large-scale problem, and so I suggested that we could parallelize the computation using different CPUs. And so he asked me, like, if we had 2 CPUs, how would you parallelize it? And my response was to parallelize the outer ith loop where we are computing the upper triangular part of the matrix. If we have 2 CPUs, we can assign different rows to each CPU. For example, CPU 1 would compute I equal to 0 where we have distance between 0, 1 and 0, 2. And CPU 2 would compute distance between 1 and 2 for I equal to 1. And by this we would have completed all the elements of the upper triangular matrix. And so by splitting the rows across multiple CPUs, we divide the workload evenly, like ensuring that all computations remain independent. And we can still use the symmetry of the matrix to copy the upper triangular values into the lower triangular values, as I show here in the function. And so then I was asked why we wouldn't parallelize the inner loop. we cannot parallelize the inner loop because it has a smaller computations for each iterations. So we would have more time spent in the overhead. And so in contrast, if we parallelize the first loop, the ith loop, it allows us to actually give larger chunk of work to each CPUs instead of the parallelizing the jth loop. And so parallelizing ith loop is more efficient for handling like computing with larger chunks of data. And so this was my response, and he seems satisfied. And so we will go to the next problem that I was presented with. Next, the interviewer presented me with a function that actually counts mismatches between two strings, as I show here in the red shaded rectangle. This function actually uses Python loop where two strings are zipped together and compared character by character. So for each pair of characters C1 and C2, the loop checks if they are unequal, and if they are, it increments the mismatch count. And finally, the function actually returns the total number of mismatches. I was asked how I could actually make this more efficient, and I was immediately able to recognize that Python loops are very slow because Python is an interpreted language, and each instruction in the loop is executed and interpreted line by line. And so it makes this approach very inefficient for large dataset. And so I suggested that we could use NumPy's vectorization to optimize the operation. And so as I show in the green rectangle, my approach was that since NumPy is implemented in C, that will allow us to perform operations on entire arrays at once instead of processing element by element within a loop. And so I suggested that the solution is to convert the strings into NumPy arrays and perform element-wise comparison to check for all the mismatches simultaneously, and this will eliminate for a Pythonic loop entirely. And so by applying vectorized operations with the NumPy, the comparisons in the green rectangle are performed on entire dataset at once. And I told the interviewer that by doing so we could achieve a speed up of 10 to 50 times, because I have seen this earlier in my other problems. And the interviewer asked why I wouldn't use Numba or JIT compilers, why I should not consider using Numba. And while I was aware of Numba, I hadn't worked with it. And so I explained my experience was entirely with NumPy and dealing with vectors and MATLAB. So I haven't worked with Numba. And after the interview, I actually explored what a Numba is, and I found out that Numba can often provide even greater speedups, particularly for operations like this. So by compiling the function JIT, which is an acronym for just in time, Numba can optimize even Pythonic for loops, and actually it's a alternative or is a competitive to NumPy's vector. And so what we can learn is that while NumPy is a powerful tool, we should also be aware of other complementary tools like Numba, and it would actually help us in improving the performances. But the interviewer was actually seemed satisfied with my NumPy vectorization approach. And so let's go to the next question that I was presented with. So the next question the interviewer asked me was about handling large number of text strings. The task was to compute some kind of similarity or distance or some computations between these strings, and they asked how I would optimize the process, and also they said that if 25 to 50% of the strings were repeated. And so my suggestion was, instead of comparing every string pair in the large dataset, we could first pre-process the data to identify unique strings by using hashing or text mapping. So we can actually map each string to a unique hash value. For instance, in this example, the string hello world is repeated 3 times, but it maps to the same hash value. Similarly, goodbye world is also mapped separately. So for each unique hash, we store the indices of where the string occurs in the dataset. So in this case, hello world is mapped to 0, 1 and 3, and goodbye world is mapped to indices 2. Next, I suggested that we could compute any sort of computations like similarity or distance metrics only for the unique strings, actually, which reduces the number of computations. For example, instead of 4 strings here, we only have now 2 unique strings, and so our matrices is 2 cross 2. And then always we can later expand the results back to the full matrix, and this way we avoid redundant computations. I believe the interviewer was satisfied with this solution, and it's a common technique, and I could answer this because of my experiences from Kaggle competitions, which was helpful here. Also, whenever I work on large datasets, one of the first things I do is to check for duplicates or missing data. So as this can often be exploited to save some computational time. And so let's go to the next question that I was presented with. So the final question the interviewer asked me was about handling millions of strings or data points. Specifically, they wanted to know how I would compute distance matrix or similarity matrix or any similar computations on very large data set of millions of strings, and what optimization I would suggest. And so I know that the challenge of dealing with terabytes of data is we cannot process the data at once, so we have to actually process the data in chunks or smaller batches, since the computations are independent, as we have seen from the distance matrix and or the similarity matrix. And so when we do batch processing, it prevents overloading the memory. I also mentioned that we can store only half of the comparison results because our matrices, whether it is distance matrix or similarity matrix, was actually symmetric. So we could only store the upper triangular matrix needed to be computed. That was actually computed as we saw in the earlier slides. And I also suggested that if we have like repeating structures, then most of the distances would be 0, and so we would have something like sparse matrices, or we could only store non-zero or relevant distances, which also further reduces our memory usage for large datasets. I also pointed out that any intermediate results or computed distances could be stored on a hard drive rather than in the system memory, allowing us to handle datasets that are actually much larger than available RAM. And so even though interviewer was satisfied with my responses, he further asked me specific questions on data formats like HDF5 or tools like Dask for distributed computing. So I honestly admitted that I wasn't familiar with these technologies, as my experience has been mostly in scientific projects and academic environments. And so I humbly expressed my willingness to learn, which I think was appreciated. Although I haven't heard back from this interview yet, I felt good about my responses and overall discussions, and I would like to emphasize that the questions I have shared in this video are similar but not exactly the same as the one that I was asked. So I think we have come to the end of this video. Thank you for watching, and I hope you found it insightful, and I look forward to sharing more experiences and ideas related to computing. Don't forget to keep learning and enjoy life. Thank you again.